Alright, next we're looking at the primary motor cortex in more detail. We already know that it's located in the frontal lobe, but it's specifically located in the precentral gyrus. And it's going to allow for conscious control of voluntary movements, of skeletal muscle movement. So specifically, it's going to allow for conscious control of precise, skilled, voluntary movements. And that's represented here in the motor homunculus, which again is a caricature of the relative amounts of cortical tissue devoted to each motor function. Now, information that leaves the primary motor cortex gets to travel to the premotor cortex, which is located anterior to the precentral gyrus. So it's located in front of the ridge that's in front of the central sulcus. Now, this is an area that kind of puts information together. It coordinates simultaneous or sequential actions. So it can control learned, repetitive, or pattern motor skills that we have developed. So it's very much involved in planning movements. It actually works really well with very common planned movements, and that information usually gets sent subconsciously to the cerebellum as well. Then we have Broca's area, located anterior to the inferior region of the premotor cortex, so a little bit lateral and to the front. It's usually present in the left hemisphere only, can be present in the right. More commonly, again, it's the left. And it's a motor speech area that directs muscles of the tongue. So when you're preparing to speak and move your tongue and kind of shape your pharynx and your oral cavity in order to produce speech, this is an area of the brain that becomes active. All right, next we're going to be looking at sensory areas of the cerebral cortex. The main areas that we can see highlighted here are the primary somatosensory cortex, located in the postcentral gyrus, somatosensory association cortex, located behind that, the visual and auditory areas, with the visual areas being located primarily in the occipital lobe. So you don't have eyes in the back of your head, but you do process information about vision there. And then auditory areas are going to be more over towards the temporal lobe, and then olfactory, gustatory, and vestibular cortices. Those tend to be located also kind of over towards that temporal lobe, or kind of closer to that lateral sulcus. Olfaction is smell, gustation is taste, and vestibular information or vestibulation has to do with equilibrium or balance. Alright, so let's first start with the primary somatosensory cortex that's located in that postcentral gyrus. This is an area that receives sensory information, specifically about the body. So it's receiving information from the skin, skeletal muscle, joints, tendons, and it's allowing neurons bringing in that sensory information and communicating with higher order neurons to distinguish via spatial discrimination. So it's letting the body know where it is in space. Here we see on the right the somatosensory homunculus, that caricature that represents the relative amounts of cortical tissue devoted to each sensory function. And so it's showing you that we can receive sensory information from all over the body. But there are parts of the body that will send more sensory information to the brain, specifically to the primary somatosensory cortex in that postcentral gyrus. Located behind the postcentral gyrus is going to be the somatosensory association cortex. With these sensory areas, we are going to start to see association cortices, because the primary cortice or cortex for sensory areas just receives the information and makes the brain aware that there is sensory information. So it's really the association cortices that integrate that sensory information. For example, the somatosensory association cortex integrates sensory information coming from that primary somatosensory cortex. So it actually forms comprehensive understanding of the stimulus only when we use an association cortex. So let's look at an example. Imagine you reach into your pocket and your somatosensory association cortex uses stored memories to allow you to usually correctly perceive the objects you feel as coins or keys. To simplify that, imagine you reach into your pocket, you just feel around and you feel the size of something, the texture of something, or the relationship of things to each other, and you're able to figure out what it is. Is it coins? Is it keys? Is it chapstick? So that's what an association cortex can do. It's not just the awareness of sensation. It's the integration and the making sense of that sensation. So for a visual area, we have a primary visual cortex and a visual association area. The primary visual cortex is seen on the extreme posterior tip of the occipital lobe. So it receives that sensory information about vision. And it receives visual information from the retinas. So it lets you see a pretty flower. But you can't appreciate seeing a pretty flower or think it's even pretty if you didn't have the visual association area that surrounds this primary visual cortex, because it actually interprets the visual stimuli, gives you information about color and form and movement, and lets you make a decision. It's the integration space for vision. There's actually some homeostatic imbalances related to vision. For example, if you damage your primary visual cortex, that causes functional blindness, because maybe nothing's wrong with your eyes, and information can still go to your brain. But if the primary visual cortex is damaged, your brain cannot become aware of that visual stimuli. Or what if you damage the visual association area? That results in individuals who can see, so visual information can get to the brain, but they can't process it. They can't comprehend what they're looking at. So again, our vision areas are located in that occipital lobe. You can see here on the image that primary visual cortex is at the extreme tip of the occipital lobe, and the visual association area is around it. Alright, next we're going to be looking at auditory areas. The primary auditory cortex is located at the superior margin of the temporal lobe, so kind of upward towards that lateral sulcus. And this receives information related to pitch, rhythm, loudness, so basic information. In order to determine if the pitch, rhythm, and loudness is a speech, a scream, music, thunder, what type of noise, do you like it, do you hate it? In order to have that kind of comprehension of the information your brain receives, we have to use the auditory association area. So it's actually the primary auditory cortex and the auditory association area that must be used together to help us process sound. There's another area called Wernicke's area, again usually in the left hemisphere, that includes part of this auditory cortex, and it's going to be responsible for hearing speech and kind of picking up on information like someone using their hands to talk. That type of information can be relayed to the Wernicke's area. Alright, so for hearing, our auditory association area and primary auditory cortex is located superiorly on the temporal lobe, so it's located close to that lateral sulcus. Next, we're going to be looking at the olfactory cortex. So it's located more medial to the temporal lobe, a little bit closer to the insular lobe. It's a part of one of the primitive brain vesicles called the rhinencephalon, and that includes parts of the cerebrum, includes olfactory bulbs and their tracts. And through the course of evolution, we've seen this area in humans taking on new functions like emotion and memory and not just smell. So there is a region, the olfactory cortex, that is just a region for conscious awareness of odors, but it can communicate to other association areas and let us have emotion or memory related to smell. So here you can see the primary olfactory cortex down there at the bottom. It looks kind of like a little curlicue in dark purple. So it's down there below the thalamus. Alright, next we're going to be looking at the gustatory cortex. So it is involved in the perception of taste stimuli, and it's in the insula. Now we would need an association cortex, which is really more of the general association cortex to help process that information. There's also a visceral sensory area in the posterior area of the brain. It's near the gustatory cortex, and it allows for the conscious perception of visceral sensations, like if you have an upset stomach or full bladder. That type of information will get to the brain and be deposited at the visceral sensory area. Then there's the vestibular cortex. This is a posterior part of the insula. It's adjacent to the parietal cortex. And this vestibular cortex is responsible for the conscious awareness of balance. Again, if it's just the cortex, it's probably not doing a lot of integration. It's not doing association. So things like the gustatory cortex, the vestibular cortex, and the visceral sensory area, they're kind of just receiving this type of information. Alright, so here's a quick review looking at the many different areas of the brain, both motor areas more towards the front and sensory areas more towards the back and lateral sides. Make sure to review that video, and we're going to continue on next and look at multimodal association areas.